What's going on, guys? Xiangqi here. In this video we'll continue working on our Xiangqi Stockfish. So I don't even know what in particular I'm gonna be doing within this video. Well, actually really lots of things needs to be done, and well, actually I'm going to work on search, but I just thought that without having even a placeholder for evaluation, it's not really that kind of trivial to be achieved. But anyway, I probably still can just return 0 from the evaluation function for now. So anyway, the idea is just try to make engine searching as soon as possible to actually already being able to play a game with it and then constantly improving. So since the last video, I've moved the perf testing routines from, well, it doesn't matter really that much what exactly I did, so I would better demonstrate how this works now in particular. So by the way, yeah, info string, one of the most interesting things. So we still can print the board. Okay, so I can probably make this a little bit bigger. So we can still print the board, and if we just say go depth whatever, it doesn't do anything. It's not yet implemented, so I've disabled all the previous stuff that was there, but I've restored the go perfed. So go perfed 1 for this position. Okay, so we can say go perfed 5, and we go searching, and if we just set up a different position, like position FEN, then I'm not sure if okay, it's probably not really here. Okay, let's go for the FEN. Yeah, I'm not sure if the position, if this like would get initialized. Actually, it should be, I mean, not bishop and knight, but elephant and horse being enabled there. Okay, so let's actually try this. Then you test it. So position FEN, and let's have a look. Yeah, it seems like it parses this sort of a position as well. So we can also say go perfed. Let's say how many perfed? 5. Perfed 5 would be just fine. So it should be this number of nodes here. So we have 5, 3, 1, 1, 2, 9, 9, 6, 7. Yeah, perfect. Just awesome. And yeah, so actually now perfed is also available within the UCI loop. So at very least, this is the very first use case for the engine, even in the current stage. Well, I don't actually promise that by the time when you would be watching this video, the UCI will still be available, but I will try to keep that. So now the next thing to consider. So just to give you an idea, what am I trying to do basically? So here within the UCI loop, where we did parse the go command, here it is. So before it was like threads search here. So the threaded search was invoked, and really lots of code in Stockfish is actually related to threads. So I'm not going to be obviously using that because it just violates everything I've done so far, or maybe it's better to say that everything I've done so far actually violates what it was done before, obviously. Yeah, but anyway, so now I've created a custom entry point for a search, so to keep the code that I'm writing actually separated from the original Stockfish's code. So the plan is very simple. So first I'll try to make a proof of concept search just to make sure that it actually can search and output the best movement, play at least something, and then I'm gonna be improving the search using the actual Stockfish's code, but not blindly copy pasting the entire search. Obviously it just won't be working literally, but just reusing those parts would I be able to reuse that I like, etc. But again, like it's not gonna be the clone of Stockfish's search, so I'm going a bit my way. Not because it would be better, but rather because I'm just too stupid to reuse the Stockfish's search from scratch, and also because I've ruined everything already, so it's no longer possible. So I hope you understand this, guys. But anyway, this should be really interesting engine eventually, and one of the most interesting things that, bearing in mind the fact that we have the position object being encapsulated and the source code being split into the files, so nothing can actually stop us from improving this constantly later on, because my previous implementations actually were relying on the global variables for position and the board and all this stuff. In that case, let's say threads were not an option anymore, and some other limitations. But with this sort of an approach, it's still possible to bring it back to the state how initial Stockfish was. But anyway, I think this is really interesting to go your own way, because, well, at very least I'll try to make it stronger than Fairy, Stockfish, and Chameleon. And for CNC, this is really possible. For international Western chess, I wouldn't ever dare doing this, but for existing ports of Stockfish to play CNC, I think this is really doable task. Well, at least I hope so. Maybe I just too optimistic. It's hard to say. Anyway, so here is the entry point. Here is the new function, which serves as the entry point to the search when the go command gets invoked. And before this, actually this main thread search was called, so we don't really need all of this stuff. And but I did reuse this if limits perfed, then we go for perfed. So just to make code within the UCI loop look like it did look before. In original Stockfish, the iterative deepening loop didn't actually start here, but in our case, for simplicity, I will actually start the iterative deepening loop right over in here. And also, just because the move scoring would be done within the move generator, right? And also I'll need to keep track of the structures for move ordering, like killer moves, history moves. I also want to make the principal variations storing also being separate from whatever methodology is used in Stockfish, because it's not really doing anything in terms of strength, but for simplicity it's really better to use the way I used to do it, because I'm just really comfortable with that. So yeah, now it's just need to take a decision. What should I be, what am I gonna be working on next? Well, if I just go for a search straight ahead without move over, it would be really slow as hell. But on the other hand, and yeah, without, I guess, I'm sorry, just it's a bit of a downside of the live coding that you don't really know what to do. Okay, so, well, we could work on a separate module like this evaluation placeholder. Maybe I should go for that. So where is the evaluate? Search. Let's see, evaluate CPP. Here it is. So there should be something like the main evaluation. Okay, so the evaluator for the outer world. Okay, this is what we need. Returns a static evaluation of the position from the point of view of the site to move. Yeah, this is exactly what we need. Evaluate, and I guess this is what is actually used. Nope. I think this is what is used within the quiescent search. Should be, really should be. Didn't yet have a look, but it should be really. Evaluate. Oh, so they're even using the entire namespace. Yeah, this is cool. So in this case, I guess evaluate may be called yeah, just directly straight ahead. And yeah, it's obviously it's done many times. Yeah, it's totally clear. And within the quiescence, so we can just say valid and the position is taken. Yeah, this is nice. So okay, let's start butchering stockfish. So what do we need to do? Evaluation trace. Yeah, this is really nice then for stats. I just wondering, can I safely remove this? Probably not, but maybe this is gonna be easy. Well, obviously cleanups is really big job that is awaiting for me, because I'm really creating lots of garbage code. I mean, like the brilliant stockfishes code becomes the garbage code. Okay, so where is this used? In function trace eval and define reference to trace eval, but where from? Okay, forget this. It's not essential really. So yeah, let's go to this main evaluate. Let's go to this main evaluate. So this should be possible to. So what type? Value. Okay, type of the value. So like this. So still working. Cool. Okay, and now I should be able to get rid of all this stuff. So let's just call it score, and eventually we want to return score. My evaluation function is just a simple, just one function, nothing much. I would also like to add my disclaimer here, like everything above is not used and would be removed later. Okay, so here is the limit for our code, and actually we need to say regarding the everything below as well. Usually I use the most bottom function. Well, doesn't matter. So yeah, and here would it be working? So still composer runs. Okay, value is unused. Yeah, this is fine. Okay, so now I want to grab the p-square tables. I'm not gonna be sticking to stockfish's p-square tables, and even if I go for tapered evaluation, which is really on the cards, I would be using my own schema for that and not sticking to stockfish's p-square tables, because again, like they are optimized for what was in stockfish before. And just to give you an idea, guys, just to give you an idea, you might wonder, like, why actually do I do this within the stockfish's code if I literally butcher and everything from stockfish? Here is the reason. So here is the main function I actually need. Let's say alpha beta. Where is the alpha beta function? Nope. Okay, here it should be here. It should be somewhere. Okay, here it is. Void value search. Yeah. So here is the function. So here is the code that makes Stockfish's search so damn great and fast. And this is still the code. So there's still like really lots of all this steps, step 7, step 8, etc., etc., etc. All this stuff makes search cutting really lots of unnecessary nodes, and the values that are used are optimized by running this search on running Stockfish on running numerous games basically. So this search is jam really, and this is still the search, and this is still, so this is literally the only function that I need eventually in order to make use of within the engine. And well, and Quiescence, obviously Quiescence is really fantastic as well. So Quiescence is also on the cards. So I'm going to be using these two functions as the source of inspiration, but again, like not blindly copy pasting them, but instead just copy pasting it with open hands, with with open eyes. Okay, but not everything, but just step by step, piece of code block by code block, and with an understanding of what am I doing basically. You might wonder in this case why I'm actually sticking to Stockfish. Well, that's because as far as I don't know how to code in C++, believe it or not, I would never set up this the entire project structure, believe it or not, and I really don't know all the C++ specific things like string parsing and other things. And here everything is already done, so it feels like just a bit faster. Well, obviously it would take ages to get rid of all the unnecessary code later on, but I don't really think that is going to be... Well, that's going to be interesting because butchering Stockfish allows to learn its anatomy, basically, and this is really cool because I would end up understanding how the entire Stockfish works at the very end. I think this is really beneficial. Okay, so, but for now, I really need to get done with the evaluation. So let's go to my Wukong CNC. And let's go with source. I already have nicely tuned values here. No, it's not the GUI. I need the engine, and here, and I need the evaluation. So here is the reference. Where did I take this from? Yeah, it's gonna be a bit of a pain to okay. Hold on a second, guys, just sorry. I'm just looking for a proper syntax for defining multidimensional arrays, and how in particular I'm gonna be doing this here. So probably I should. Yeah, it's unfortunately takes a bit longer than I thought. Okay, let's have a look. Let's have a look at my BBC. At least it's written in C, and something similar we already have there, right? So just don't really want to write many things from scratch. Evaluation. Oh, I just replaced it, and you know, I just need some. I need some older versions. Let's say this one. Okay, yeah. Okay, so they just go in one by one, and then I can use these offsets. So Okay, so open an end game. Okay, this is gonna be helpful. Okay, so let's start. So evaluation types. What the heck is this? I don't even remember. Oh, it's probably those used and unused. Okay, let's grab the entire thing. Not really that much. By the way, this is the entire evaluation. This is the entire evaluation for my Wukong CNC engine, believe it or not. Yeah. And this is the entire evaluation function, believe it or not. It's really small, right? So this is it. Only material and p-square table. That's it. But it already plays quite pretty reasonable CNC, especially if you can't play CNC as a human, you're getting crushed and made all of the time. But even from the engine perspective, it's not really that bad. So yeah, it's really miserable. It's really kind of like a placeholder, but this is exactly what we need now. So I'm going to evaluate CPP, and let's go. So, okay. Well, later on, really all of these values might be changed. But for now, okay, so this would be const. Let's make it integer for now. Let's just make it integer. So at the moment, so for now, I just want this to get compiled. Nothing much really, just to get it compiled. Let's make this integer as well. All the things like renaming types to some proper, I know it should be value apparently. Material weights, yeah, this should be value type as stated in Stockfish. So p-square tables, this would be two-dimensional array. By the way, can I actually use, well, if I use an empty placeholders in that case, but I could have go for this, but okay, just forget it for now. So we need no, even not like this, like this. So this const value pst, I'm not sure how, so this would be 154, and this is the number of arrays, so not sure how many still there. Okay, we'll first go for manual probing of this stuff, obviously. Okay, and these p-square tables are really fantastic, I need to say. And also, yeah, hold on a sec, also another issue here is that the way they're currently defined with the swapped colors, I would need to, okay, doesn't matter at the moment really, because the board NDNS has changed. I'd also need to change, but I'll need to change a couple of lines of code within the evaluate function itself. Okay, so this mirror square, okay, let's get rid of this for a while. So for now I just want to make it get it compiled. That's all I want. For now I just want to get it compiled. Oh man, are you kidding me? Oh, oh damn. Yeah, let's make them integers. Yeah, because it considers every single one to be. Yeah, let's just make them integers. Yeah, this is insane. Okay. What would be converted into value type later on? Okay, unused parameter position. Score is unused. Yeah, now this is nice. Now this is really nice. So how many we have? So 1, 2, 3, 4. So we have 4 and like this. So this is like, so 0 is the pawn, 1 is the knight. Well, I can probably just use switch case statement for a while. Yeah, so let's forget about this part at the moment. Yeah, a switch case statement would be fine as the placeholder for a while. Okay, so still working. Okay, so now let's go to types. I also need this mirror square routine, not the routine, but lookup array for mirroring squares. A little bit of a downside that, yeah, I've just realized. Oh man, I just realized that square numbers. Hold on a sec. Did I have? Hold on, guys. The first is equal to 23. 10, 24, 5, 6, 7, 8. Oh, I just didn't define. It would still be working, but I just realized that unfortunately, I've used the squares to define the off-board squares as well. So the square names do not match. So this square should be A1. A2, A1, B1, C1, etc. Yeah, but the reason why I did that, well, okay, so sorry guys, I'm just thinking for too long. Probably should have stopped the video. Just looking for a way how properly to mirror this array. So I won't be having zeros. I will be having, so A0 would be here. And what the value do I have for A0 in Wukong. It's not visually seeing that great. No, I don't even have the A0 square here. I'm just trying to understand how in particular should I swap. By the way, hold on a sec. This is the same NDNS used in Vice and TSCP, I believe. Okay, here it is. So it starts from the highest and then going downwards and ends up with the lowest. So probably should be starting with this. Probably will go for a bit of automation. I'm sorry guys, so you can probably skip the next 10 minutes of this video because I'm gonna be doing some boring stuff now, but just for history I would keep recording this. So I just create a Python file here to want to create a list. Because I'm not going to be doing this manual, obviously. Python 3, nope. Damn. Okay, so now I need to parse this. And so I can split by the comma. Okay, and I want to strip everyone. So for strip in every single coordinate. Okay. And just trying to print them from the opposite side. Is that gonna be fine? So for coording chords, let's say for index in range from 0 to the length of the chords, and no, from length of the chords and to 0. So let's make sure that I do loop from 153 Okay, doesn't work like this. So let's say mirrored index would be 154 minus index. Let's have a look at the mirrored index. So starts from, no, let's say 153. Okay, so starts with this and ends up here. Okay, good. But probably, yeah, probably I need to make it a little bit different. So let's say from range from 0 to 11, and this would be rank. No, so rank would be from 0 to 14. And this for file in range from 0 to 11. So just to fit the current board layout. And let's say square would be rank multiplied by 11 plus file. And let's print the square. Okay, and now the mirror square would be 153 minus square. But now I would already be able to add new lines to console. Mirror square. Okay, the same, but now would I be able to actually print the chords indexed by this mirror square? Okay, and I can also do it like plus, comma, and space, right? And I want at the end not print in the new line. Okay, and every rank I want to print the new line. Okay, so this in theory should be the mirrored array. I'm not sure though. We would now go for testing this. I'm not really sure, but let's go and try. So all this would be integers. Okay, paste. So at very least, this still this should compile. We'll get back to that window one day if necessary. Oh, sorry. Just a small syntax issue. Yeah, and I'm really tempted to figure out whether this mirror is just working nicely. Yeah, no, I guess probably we'll actually part one. Probably this video would stick to only evaluation, and then when it comes to search, I think I will first draft the initial setup to actually make a play, at least somehow, And then by the time when I would be adding new features from Stockfish to search, making it stronger every next time, that would be covered within the videos. That would be more interesting, because yeah, there's really lots of routine that it's better just to highlight and showcase rather than live code. And so yeah, we just end up with this evaluation, and then I will already show the ready-made search. Yeah, I think that's the way to go. Okay, go perf 1. Yeah, okay, so still alive. Okay guys, so evaluation, evaluate, value, score. Yeah, another problem is that these data structures are only visible from, they're not global, so it's a little bit of a pain. Okay, doesn't matter really. So let's go. So score would be equal to 0. This would probably give me an error. So this should be value like this. Here we need to loop over the squares. So square 154. Actually, I can use the square number here. Square plus plus. Okay. So if position dot piece on and the square is not equal to offbar, this should be working. Then if there is a piece, actually, so if there is a piece, in this case, let's just print the piece for a while, and I want to return if position dot side to move is equal to white. So this is needed for Nigamax framework. So returning the side relatively to the side to move. Okay. So let's see if it compiles, by the way. And I simply want to print a piece, just to give you an idea that that is a non-zero value. So what is returned by this function? Okay, and we don't yet have an access to evaluation, so square from okay, so square from square A1 yeah, a bit of a misleading stuff regarding the square names. So square names do not actually correlate with the actual coordinates. This is not really that great, but I think this is the least evil. Okay, what? Oh, and here we need to say plus plus square. And now within the UCI, I'm wondering how to call the evaluate. So that is eval, right? So trace position. this is what is called here. So does it reuse the namespace of eval as well? Trace eval is definitely the function from here. Oh, no, trace, no, it's not. Whoa, what a surprise. So let's have a look at trace. Oh, this is the trace eval. Okay, eval trace, yeah, this is what I need, copy. So if token is go, or token is eval, so if token go, otherwise we just go for evaluate position. And what are we calling this this function directly from the UCI loop? So let's go for this. Okay, it's just easier to debug. I could have actually run this from the main CPP, but this should be fine as well. This should be fine. So okay. It's hard to imagine what can go wrong here. Okay, let's just comment out something to figure out where the issue is. So I'm not doing any rocket science here, so just want to loop over the range of squares for all the board, and want to have a look if there is a piece. So we've been doing this many times before, so what can go wrong here? Kidding me. Okay, let's go debugging. So printf evaluate, and here let's go square and square. So let's see if we do loop over squares. So where is the issue rising? Sorry. Okay. So eval, what the hell is this? Info string evaluation enabled. Hold on a sec. It's just something wrong within the UCI itself. Oh no, hold on a sec. Oh, this is probably, oh, this is within the bench. What have I done? What have I done? This is just the wrong place. Totally wrong place. Sorry guys, just pasted that into totally wrong place. Token eval, and here I want to say evaluate, and the position. Yeah, now they should be working really. Now this has to work. Okay. Okay. Yeah, now we have the squares. Okay, good. So let's get rid of this stuff. Yeah, because it was calling trace eval, which is no longer an option, obviously. So yeah, now I want to print a piece, if any. Okay, and then I would like to start initializing the stuff. So this would be the piece, and whatever we have. Okay, BST index, yeah, probably not gonna be using this because of will you switch case statement. Piece color, yeah, this is interesting. Not sure whether integer or, so let's just get rid of unnecessary things. Do we? Okay, eval. Yeah, cool. So we have all the pieces now. Yeah, this is awesome. Okay, we do keep track of all the pieces. So piece color, this is within the types. Types. Piece color. So this is color. Okay. So piece color. This is the color type. And we got the type. Okay. So now material score. Material weights. Do I have the material weights? Yeah, I got material weights. Okay, good. So score plus equals material weights, and I just need to convert this to value. Okay, and before we return, I want to I can actually use printf, just a faster way. So score and decimal, then convert to integer type, and now literally reusing, no, let's make it like this, and either score or minus score. So this should be enough for debugging. So if I did everything correctly, should be printing score of 0 because we have equal material unused piece color. Yeah, still unused. Okay, doesn't matter for now. So let's go for eval. Yeah, and we get score 0, which is correct. So if we now, yeah, let's actually start with debugging material count. So, well, I can do it already. Okay. Let's run this one more time. So just to avoid printing those pieces, and I need to grab some FEN. So let's grab the initial FEN. And I would be just removing some pieces. So let's say get rid of black rook, and this should give me plus 60. Okay, let's have a look. So eval and position FEN. If I now paste this FEN, Let's have a look. So we did remove the rook and eval, now it should be 60. Okay, if I remove this one, say, it should be back to 0. And we can assume that the material count is actually fine. So let's have a look at the position. Yeah, now this rook is removed. Now it should be 0 again, back again. So eval, and we have 0. Yeah, this is nice. This is really nice. Okay, so I have the 0 evaluation. Not that bad at all. This is quite nice. Okay, so it's quite simple with material, but it's going to be a little bit more complicated with the piece types. And I can actually also extract the type. So is that a piece type? Control F, piece type. Yeah, piece type. Okay. So, sorry. Piece type equals piece type of the piece. Oh my god. And so I can switch by the piece types to make the code a bit less. So score, let's say piece square table positional score. So switch and yeah, switch the piece type. And the case of, so what types do we have? Okay, pawn, bishop, advisor, king. Okay, so we have pawn, knight, cannon, and rook. Only these four. So pawn, knight, cannon, and rook. So case pawn, and let's break here. Case knight, and spray here. Case cannon and rook. Okay, case cannon and break, and case rook and break. Let's try to compile this to make sure it so compiles. What? Not handled. Hold on a sec, what the hell is this? Enumeration value advisor not handling switch. Oh, okay, so maybe we should bring this to integer type. Okay, yeah. So switch probably can only operate on integers, even though the piece type is actually the integer as well, but from the compiler perspective, it's the integer of a piece type, the specific one. Okay, piece color is not used yet, but we will use this. Okay, so just wondering how to make it let's say if piece color is equal to white. Yeah, let's create some. Let's create this score site equals to make it -1, or hold on a sec, you can just say score site equals to piece color equals to white, and if yes, then 1, otherwise -1, and we would be multiplying by the score side. Okay. Hold on a sec. No, this sucks really, because okay guys, I'm sorry, I'm not going to be optimizing this for code size, so yeah, just and we actually don't need ever to extract this as well, so extract piece. We don't need this, so let's just switch the piece, so we will have white pawn, white knight, white cannon, because there is a mirror square option as well, right? And the same for black guys. So black pawn, black, save. Yeah, now this should be fine. Okay, so now white pawn, we need to say here we say score plus equals, and now we need to reference p-square table, and assuming this current layout we should mirror for whites. Yeah, it's a bit not that great, but it's better to have the values from the side to move, from the perspective of the side to move. So I could have probably, well, I could have mirrored them using my Python script, but I'm not, as far as I'm not really sure, yeah, that it kind of works. Okay, let's try. Pawns. Yeah, okay, let's try. So copy and paste. So this is how it would be if mirrored. Just to prettify the layout. So print I need to say multiply by the length of I'm not sure if what I'm currently doing is going to work, but let's have a look. once did this. I don't remember how exactly. Yeah, this would be the fastest to fix. Sorry, I could have done this programmatically, just don't really want to spend too many time for doing that. So I just want to keep this from black's perspective. It's, I mean, like white would be on the top, like regarding the board and the NS. It's not the best ever thing to consider, but at least this would be a bit more how it's usually made, how it's usually done. Okay. 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 Save. And we can already test whether this approach kind of works with the pawn or not. So do we have, so, oh my god, how to convert this in my head? So it starts from here. One, two, three, four, and okay, let's have a look. Kidding me, man. Oh, yeah, surely. Just want to see the board before proceeding. So 1, 2, 3, 4. Okay, so some of the pawns should be evaluated already. So knights. So it should be, so the central pawn should be evaluated as 4, and this should be evaluated as minus and minus. Yeah, but I just don't even know how to. Yeah, so it's not an easy thing to extract the coordinates. It's a real pain. Could have created another array. The maps. Hold on a sec. If I map, say, A1 to this one. Oh. And I just use, hold on a sec, guys. This might be on the cards. Hold on a sec. If I just say, okay, map, use squares. So let's say this would be const squares. Hope the name is not taken. Const squares. Okay, is it gonna compile? So does it allow me square then not? Okay. If it just allows me to have this variable name, a zero size array. Okay, nope. Square. Just wanna know if it really allows me doing this. Yeah, it should be. So like this. Then like this. It should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, and also I need to get rid of the first and the last file. And this one as well. I know it's probably not easy to understand what am I doing now, why, but I hope it gets clear soon. Okay, let's try to compile. So now I want to use the squares. So now I can use these names to reference the actual squares in theory. Well, let's start from not non-converted yet. So let's try to, let's say here. So let's try the here. So square and A, B, C, D, E, F, G, H, I, J, K. No, so A, B, C, D, E. So E, well, it's not gonna be E0. This is gonna be E9. So this is gonna be the square E9. So for rooks, so PST, PST rook and square E9. Square E9 on the rooks, right? So, and yeah, this should work already. Okay, so at the E9, I'm testing several things in the row. So first this mapping. So I want to use this. But hold on a sec. No, not like this. I need to say no. This would not work. I need to say squares. Yeah, like this. This is the way to go. So this should output 12, and if I then switch to E0, it should output 16. So let's try to go for this. So eval. Oh man, square. What have I done? Nope. Hold on a sec. Didn't mean this. So something has gone wrong. Okay, let's start from this one. Okay, let's start without mapping. So let's for now this should be, so 1 2 3 4 5 6 and 3. 1 2 3 4 5 6 and 3. So square F12. This index correct? 0 1 2 3. Yeah, it should be. Sorry. Okay, good. So we have this square root 9 equals to 12. Okay, I'm sorry guys, just been a little bit distracted. So, okay, and if say I try the square E0, it should be 16. Yeah, but hold on a sec. Now I want to have the same value. Square F12. F12. And where is the F12? Oh, we don't even have F here. What the heck is that? So 1 2 3 4 5 6 7 8 9 10. Oh, hold on a sec. Yeah, square is F12 is available. So the index, so 1 2 3 4 5 6 7 8 9. Oh, it's not gonna work. Well, okay guys, so this idea sucks, at least at the moment. It really needs to be worked out, so maybe I will do this one day. Okay, at the moment it's literally enough to, actually I only need to make sure that the mirroring of the squares is done correctly. So how can I, so square F12, so this square, so if I use the mirror square, for F12, for this one, it should give me 16. It should give me this, if I understand anything properly. Yeah, seems like it's working. Okay, so let's start with the pawns, and then we'll see if this works or not. So 4 pawns, because pawns are the only correct array at the moment. So for pawns, so for white pawns, we want to say plus equals and PST indexed by 0 and by the square, right? Yeah. And now this should give a positive value because it would be evaluating also. Well, actually, no, this would be, damn, this still would be 0 because it's just plus 4 for pawns. And hold on a sec, did I actually restore? No, hold on. So this would be, this still would be 0 because 4 minus 2 and minus 2. Yeah, it's a bit of a pain. So yeah, it would still be 0. Okay, so let's try, so remember that it's minus 2 minus 2. Let's make them 4 and let's make it this one 3 and this one 4 to check this left right mirroring. So this should be also handled. So this would be 4 plus 5, it's 9 plus 3 should be 12. So now red should be plus 12. Okay, good. And now for black. So for black pawn, this would be score minus equal, but I want to mirror square like this. And now the score should be equal to 0 back. And if this works, then I'll convert the rest of arrays, and it means that everything is working properly. Otherwise, I would need to mirror white pieces or red pieces. That's not the way to go. Oh, damn. 24. This is horribly wrong. Oh, minus. What have I done? But yeah, so this should be correct because 12 and 12 is 24. Yeah, now this should be 0. Okay, and this means that we're almost done, guys. Yeah. Okay, now it should be 0. Okay, good. So we got this 0. Quit. Okay, let's go for the rest of the pieces in this case. So we don't need this anymore, so it seems like to be working. So first going for translated copy. Well, I can actually reuse this pawn. Paste, save. Okay. Can still reuse my stuff. So these were the knights, I guess. Yeah, how these were the knights. Okay. Oh, what have I done? Damn. Okay. And okay, good. So this is index of 1. So, well, that's actually, as far as we don't really have anything else apart this be square tables, just go for a bit of a simplification. So this would be the night. Okay. And so here, and the score should still be 0. Well, actually, I'm not really sure what's the penalty for knights. Yeah, it's a bit of a strange. Well, actually, yeah, we don't really see much there, so probably. Oh, okay. Hold on a sec. I just need to restore the pawns back to -2. To -2. And oh no, -4. These are the initial squares for knights. Yeah, so this is it. This is good. It's actually at 8 here to the center, 4 here. Yeah. So yeah, it should reflect the real thing. Yeah, still score 0. Good. So we need the score equals to 0 after all, eventually. So now let's go for cannons. Copy, paste, and run. Copy. Paste. So okay. Okay. So yeah, these are the initial squares for cannons, I believe. Okay, so index 2 and well, to make 100% sure that this is correct, I would be able to do that when I see how it plays, because it plays some weird stuff. That means that something goes horribly wrong. Okay, so far it seems to be just fine. Okay, let's go for rooks and save. So it didn't change any values, right? Okay. Oh. Okay. So same thing for rook. So this would be index 3. And same here. Yeah, now it looks more or less just fine. So just a placeholder for our evaluation at the moment. So we don't really need this stuff anymore. Okay, we don't need this anymore. We don't need this anymore. And let's go. So still the evaluation should be equal to 0. Yeah. I don't say that I didn't do any errors here, so there might be some, but generally, well, I feel like this should be just fine. This really should be fine. So just a few more lines of code than I expected initially, but it's not really that big deal at the moment. So let's have a look. Evaluation score equals to 0. Good. Okay, guys. So yeah, from now on, already this sort of an evaluation function is enough to make engine playing the game of Chinese chess, believe it or not. If only we had a search, obviously. So I get rid of all this stuff. Okay, let's go for a final build. So yeah, I will now prepare some search, a very basic framework for search. So it would be more interesting to kind of like adding up some nice cool features from Stockfish to make it stronger constantly all the time. So yeah, now let's have a look what we have so far. So we have print in the board, we have the evaluation. Yeah, it does nothing because I've just dropped this print line. Okay, so it's probably probably okay, doesn't matter really. So and the perf should still be working. Okay, nothing, hence no sec folds. Yeah, I really like it. Yeah, so this is cool. So from now on, it should start getting more interesting, basically. Yeah, it should start getting more interesting. Yeah. Okay. Yeah, this should be on the cards. Okay, guys. So yeah, this is it from my side. Well, maybe just a little teaser for the next regarding the next videos. Just probably to share what I'm gonna be doing next for those interested. So in the search, where is the search? Here. I will draft a very simple. Where is my sync search? I will draft a very simple iterative dependent routine here. Also need to figure out how am I going to be handling the most basic data structures. Well, actually, Stockfish has this stack, which is something similar to what I'm going to be doing. But again, like, it's just easier to make a new one rather than adjusting this for the purposes that I need. And yeah, maybe a bit of a duplication, but I think that's not a big deal. So I would have the killers just like here. The ply is getting tracked by the position, so it's no longer within the stack here. So I have this in the position object already, just to give you an idea. So the ply is actually now search ply. It's here. Okay. What else? Well, probably we could have the history array, probably the principal variation one. well, it's hard to say really. It really needs some workout. So I could say something interesting, something reasonable. But really, yeah. Also, yeah, I definitely need to score the moves with the move generator. So the moves would get scored. The moves would get scored here, just before being pushed to the move lists. Okay. So yeah, also the score with the moves is also on the cards. And then it should start being really interested. Well, okay guys, this is it from my side. Thanks for watching. Until the next time, and take care.